Hello everyone, welcome to Omega Tuition Center. So today we are going to discuss about electrostatic charges and fields, that is in class 12. Okay. The first question is, a cup of water contains 250 milliliter of water. How much positive and negative charges is there in a cup of water? So that means here a cup of water is given which have amount that is 250 milliliter. We have to determine how much charge is present inside the H2O. So if I want to write the first, that is a cup of water contains 250 milliliter, that means 250 gram, because we know the 1 milliliter equal to 1 gram. So we can write 250 gram of water. Water, that means H2O. Okay, so we know that the molecular weight of water is 2O equal to 2 into 1 plus 16 equal to 18 gram. Okay, so that means inside the 18 gram they have Avogadro number of molecules are present. So we can write that 18 gram equal to Avogadro number, that is 6.023 into 10 to the power 23 molecules are present. So that means in the question that is 250 gram is given. So that means we can use the unit rule. So we can write 250 gram. So that is basically equal to 6.023 into 10 to the power 23 into 250 by 18 molecules. Now the question is that how much molecules is given here. So we have seen that the molecules is 6.0 to 10 to the power 23, 250. So now the question is that what is the charge? We know that for H2O, for H and for O, there is 1 electron and similarly 1 proton. And for oxygen, 8 electron and 8 proton, right? For H2O, we have write that, we have to write it here, that is H2 and O, that is 2 electron and 2 proton and 8 electron and 8 proton. So that means if I just take it, so 10 electron and 10 proton, the charges are given as electron and proton. So we have seen that same number of charges is given. For electron this is negative charge and for proton is positive charge. However, it is the magnitude is 1.6 into 10 to the power minus 19 coulomb. So we can easily write the whole thing in uppercase, that is 10 into 1.6 into 10 to the power 23 charge. So we have converted the molecules into the charge. So equal to, if you just calculate this, you have 1.33 into 10 to the power 7 coulomb. So that means we can say that inside a cup of water, that is 250 gram, we have 1.33 into 10 to the power 7 coulomb charge. I think it is understandable to you. So let me discuss about the next problem. The next problem is basically two small spheres each having mass m kg and charge q coulomb are suspended from a point by insulating threads in each L meter. So let me first draw. So a thread, two thread, one is L meter, another is also L meter. The thing is that these have a charge q and these have a charge q. The same charges q. We know that the same charges will repel each other. So if I want to draw the vertical line, we can draw that it will be along this direction. The force will be, the repulsive force will be along this direction. Here, the having the mass m kg. So we know that for if a charge or if this sphere have a mass m, then there will be a gravitational force which is acted downwards. So that means the force is mg. If you remember about the mechanical calculation and the mechanical chapter in class 11, we are also have this type of figure. So in this type of figure, when a string is given of length say L, then we have also already there the tension T due to this thread. So it is given that the angle theta is the angle each thread makes with the vertical when equilibrium has been attained. So this angle is theta, similarly this angle is theta. So what do you mean by the equilibrium? Equilibrium means suppose if I want to place any box here, how we can say the box is in equilibrium or the box is in rest? So that means whatever be the force will be applied inside the box, the net force will be zero or it is balanced. Similarly, if I want to draw the same figure here, then if I draw a line, then this angle is theta. So similarly, the parallel angles. So you can write this angle is also theta. If this is a tension T along the thread, then we can write this is angle T. So according to vector component, we can write this is a T cos theta, and this component will be T sin theta. Similarly, from the equilibrium condition or balance condition, we can write that T sin theta equal to the force between the repulsive force between two charges, and T cos theta equal to mg. Therefore, if I just divide equation 1 with equation 2, we have tan theta equal to f by mg, or we can write that f equal to mg tan theta, right? So what do we mean by f? F is the repulsive force between two charges. We know that according to Coulomb's law, the repulsive force or the attractive force can be written as a 1 by 4 pi epsilon naught into the charge multiple of this charge or product of this charge, that is here q and q, by the distance between them. So if this is L and the angle is theta, then therefore this is L sin theta, and the double will be 2L sin theta. So we can write easily 2L sin theta whole square. So we have to put the value of f here, then we can have, or 1 by 4 pi epsilon naught into q square by 4L square sin square theta equal to mg tan theta. Therefore, we can write by just rearranging the values from here to from LHS to RHS. We can write q square equal to 4mg L square sin square theta into tan theta into 4 pi epsilon naught. So we have this expression that is given that we have to prove according to this according to the question. Then we can write, we can prove this expression. Okay, so let me discuss about the last problem of today's class. The last problem is basically A simple pendulum consists of a small sphere of mass m is suspended by a thread of length L. So let me just draw this figure. So that means if I draw a simple pendulum is which have a thread say L, the sphere carries a positive charge Q. So it carries a positive charge Q. The pendulum is placed in a uniform electric field of a strength E directly vertically downwards. So the direction of electric field will be downwards. Okay. Find the period of oscillation. So we have to find the period of oscillation. This is what is the expression of the period of oscillation of the simple pendulum. To the electrostatic force acting on the sphere, neglecting the effect of gravitational force. So this is the important thing is that in the previous case, if you just see that in the previous question, we have written that the mg. We have written that the mg, the gravitational force. But here in this question, it is mentioned that we don't have to take the gravitational force. This is nothing but the weight. So you can write as Fg, that is mg. Then we don't want to take this into the consideration. Then we can write that there will be only one force, that is QE. So if I just take that, if I just want to hold the sphere or this pendulum bob and want to displace distance say x, right? Then we can write there will be a force due. We know that when an electric field is applied along downward direction, if there is a charge is present that is Q, then the electrostatic force on the charge due to the electric field, it is QE. Since this is a positive charge that is given in the question, so that means the direction of force, electrostatic force due to the presence of the electric field will be the same direction of the electric field. So that is QE. Okay. So if you remember about the simple pendulum case, when I just take or when I displace the simple pendulum and say the angle theta will be the displaced angle, the theta will be so small that we can take sine theta nearly equal to theta and cos theta nearly equal to 1. So here we have to take sine theta nearly equal to theta, and here the displaced say for x displacement. So here also if you remember the Hooke's law, F equal to minus kx, where k is the spring constant. Okay, so let me just draw. If I draw this line, then we can write this angle is theta and also this angle will be theta. So according to the vector component, we can write this will be QE, this will be QE cos theta, because along the direction it will be cos theta, and in the perpendicular direction it is QE sin theta. So then we have seen that when a simple pendulum or bob is displaced, then there must be some restoring force. The restoring force you can write as a Fr. Here also, if I want to just balance the restoring force, so that means there is only one component of QE force, electrostatic force is present, that is QE sin theta. Then we can easily write Fr equal to minus QE sin theta. Now let me just see what is the value of sin theta here, because the theta is this angle and this is L and X. The displacement is so small that we can take it as a perpendicular. Then we can write the sin theta. According to this diagram, the sin theta will be x by L. So we can write as a minus QE by L into x. So we can also easily compare it with the F equal to minus kx, and if I want to write the time period t equal to 2 pi root over m by k. Then we can easily write that is m by k. So here k is, if I write minus kx, then you can write 2 pi root over ml by qe. So this is the time period. We can also calculate it by in the another method. How we can calculate? We can also calculate it in the another method, that is, if I write it here, we can write is that the mass into acceleration equal to, there is only one force, that is minus qe there is only one force, that is qe sine theta. So qe sine theta is equal to minus qe sine theta is nothing but x by l. So that means qe by l into x, or we can write a equal to minus qe by ml into x, or we can write d2x, easily write it as a d2x dt square, write as a just d2x dt square plus qe by ml x equal to 0. So this is nothing but the differential form of simple harmonic motion, that is the general form d2x dt square plus omega square x equal to 0, that we have already discussed in the oscillation chapter of class 11. So from this expression we can easily write the time period t equal to 2 pi by omega. Then we can write the omega is nothing but the 2 pi root over ml by qe. Okay, now the question is that here, if you remember, this is given that when there is a, we have to neglect the gravitational force. Now the question is that if there is a gravitational force is present, then what will happen? We can easily also calculate the same thing. How we can calculate? Then the total force will be divided into two parts, a charge qe and also the gravitational force mg. Then we can write as a mg the weight plus qe. Then we can have the a or say g effective equal to g plus qe by m. Then we can also easily write that t equal to 2 pi root over L by G. If I just have to write it here, T equal to 2 pi root over L by G. So that G is nothing but G effective. Then we can write 2 pi root over L by G plus QE by M. So in this question it is given that when the electric field will be downward, but if the electric field will be upward, then what will happen? We can easily write this expression for the electric field will be upward. When the electric field will be upward, then the mg will be in the downward direction and QE, the electrostatic force, will be in the upward direction. Then we can easily write from this expression, that is G effective equal to G minus QE by M. So therefore we can write the time of oscillation for will be 2 pi root over L by G minus QE by M. Then we have calculated the same problem in a two different way. The first way we have seen that into the first way we have calculated. How we can calculate? We have just neglect the gravitational force. In the first, we have just neglect the gravitational force that is given in the question. Then we are calculating the gravitational. We have just, when we neglect the gravitational force, we have just easily apply the Hooke's law, that is F equal to minus K. When a bob is simply displaced from the equilibrium position to a displacement x, then we can easily use the restoring force. So by this, by the definition T equal to 2 pi by m by k, we can easily calculate the time period of oscillation. Also, we can calculate the same thing when we are just considering the general form of the force, that is ma equal to qe sin theta, because only the force that is balanced by in this case, and we are just comparing this term with the simple harmonic motion SHM, that is the SHM differential form. Then we have calculate it when when we do not neglect the weight of the body, that is mg. Then we can easily calculate, that is ma equal to mg plus qe, when the electric field will be downward direction, that is given in the question. Now the question is that if the electric field will be in the upward direction, then nothing but the mg will be in the downward direction, as we know that the gravitational force always acted towards the center or towards the earth crust, and QE, as since the electric field will be upward direction, so that's why the electrostatic force due to the external field on the charge Q will be in the upward direction. So this is for electric field in the upward direction. Okay, thank you.